Hello friends, this video on structure of atom part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. So if you see now, by this time, we knew that there is something called electron, which is a negative charge. But what is the charge of electron? What is the mass of electron? Those things were totally oblivion. We didn't know what is the mass, what is the charge at that point of time. Please note, what I am teaching you now is nothing but history of chemistry. History of chemistry. So I am talking about this thing in the old era where the charge of the electron was not known. So in that case, what we did was this guy in 1897, till that time the charge of electron was not known. This guy Thomson, what he did was he found charge to mass ratio. And how he found was he used this cathode ray tube and then he applied once magnetic field and once electric field, right? So if you see, once he applied magnetic field, the electrons, let's suppose, strike here. Then he applied electric field and the electrons strike here instead of going straight. And then without electric field, it goes to B. Then what he did was he somehow balanced the electric field and magnetic field in such a way that both cancel each other and the electrons strike this position itself. And with that value of electric field and magnetic field, he had a lot of calculations which will not go deep into it, but with that calculation and with that experiment, he found that charge to mass ratio of electron is 1.758820 into 10 to the power 11 coulomb per kg. This was the charge to mass ratio that was found by J.J. Thomson by using the experiment. Hope you understand what it did. So initially the electron went and struck at B. He applied electric field, it went at A. He applied the electric field is gone now. He applied magnetic field only. The electrons hit at C. Then he applied both electric field and magnetic field. You see, this is electric field and this is magnetic field, right? He applied both electric and magnetic field and he balanced in such a way that both cancel each other and the electron hit the point B. And then with that calculation he found E by M ratio. So with the observation was the amount of deviation which you see, for example, instead of B it can go to A and C, right? So this amount of deviation, it can go A or A dash. This amount of deviation of the particle or in magnetic field or electric field, that depends on the magnitude of the negative charge. It's directly proportional. More the charge, more is the deviation. Okay. Also mass. Lighter the mass, greater the deflection. Now also if you see, if it is a small ball, if you hit, it goes to a larger distance. The big rock, if you hit, it goes to a smaller distance. Similar thing here also. If the particle is big, the deflection will be less. If the particle is small, deflection will be more. The strength of electric and magnetic field. So for the same setup, if you increase the electric field, the deflection will be more. The same setup, if you increase the magnetic field, the deflection will be more. So he observed all these three. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.